So today I answered another question in the middle that I need to tell everybody. We're not going to have a quiz on Tuesday. Okay? Yeah, you clap now. Just wait. We're not going to have a quiz because we're going to have like 20 minutes to talk about stuff, and it's probably not enough time for us to have a quiz on it. So today we are going to start talking about more complex types of information. So up to this point, we've mostly been dealing with pretty simple stuff. Simple numbers, a couple of different types of numbers, but just floats and ints. We talked about strings a little bit. That's probably the most complex piece of information. Today we're going to start talking about a type of data called an array. And an array is basically a big chunk of memory that we put a bunch of things in, one after the other, of the same type. So we might have an array of integers or an array of floating point numbers or similar. You can kind of think of an array as a bunch of boxes, one after another, and we're going to put stuff in the boxes. Yes, sir?
When we call a method a main method and we do like straight bracket args, isn't that an array?
Yes, the question was, in main, we have that thing, that parameter that gets passed into our public static void main, and it says string and it has little brackets, and the question was, isn't that an array? And the answer is yes, that is an array. That's exactly what it is. So let's go ahead and take a look. Oh, I messed that up. At what an array is. An array is a bunch of values of the same type that we use one name for, but then we use indices. We use some kind of integer starting from 0 to fill it up. So, for example, this is an array. We have an array called potato, and it's an array of strings. So, made it disappear. There we go. So, when we declare an array, we're going to put whatever the type is that it contains, and then we're going to use these two little square brackets. And that says we want, in this case, we would read this as string array. String array potato. Everybody likes potatoes, right? Yeah. Yeah, that's enthusiasm right there. Yeah. So in this case, we have, this is what we call an array literal. Just like we have string literals, and we've seen integer literals and float literals, this is an array literal. And the way that we declare an array literal, the way that we tell the computer we want an array, a bunch of things, is that we use these curly braces. So in this case, we have curly braces, and then we have a bunch of strings with commas in between them. And this is how we tell the compiler that we want an array of strings. Yes?
Alright, if you do, never mind.
Never mind?
Yeah,
sure?
never mind.
Okay. If you come up with a question again later, let me know.
Okay.
Anybody else? Yes?
Aren't arrays kind of indexed starting at 0 as well?
Yes, that's true. They are indexed starting at 0. We're going to look at that in just a minute. Was there another question? Anybody else? No? Okay. So, yes, they do in fact start at 0. So what I'm going to do is I'm going to trace through as we declare and use this array through the values and the strings. So we're basically creating a block of memory that has a place for us to put values. If we want to access a value in an array, we're going to use an index. We're going to use the square brackets in an index. So the thing about computers is you always start counting at 0 with computers. And that includes arrays. So if we want to access any in this array, we have to go to potato subscript 0. So we do potato, and then in square braces we put a 0, and that will access the first element. Good so far? Yeah? So how do you think we access the next element after that? We use a 1. Yep. And that'll print me. And then if I want to access the one after that, I put a 2, and then a 3. So what do you think happens if I try to go to the fourth one?
Error?
Yeah, index out of bounds. Yeah. So some of you guys have already seen this, apparently. Yeah, it's an index out of bounds exception, I believe. Yep. It'll throw an error, an exception. So it's very important that when we're using arrays that we keep track of where we are in them and that we don't try to overshoot it. Now, actually in Java is a fairly graceful, has a fairly graceful failure method for this. Because in Java, if you go past the end of the array, it just throws an exception, right? Which is actually pretty good, because in some languages it won't throw an exception, it'll just let you write over all the shit that's there, right? So you'll have some other stuff in memory, and it'll just be like, I'm just going to write all over this stuff. And you totally screw up your memory. Does it seem like you might be able to use that to like hack stuff? Yeah, that's what we call a buffer overrun problem, right? And it's super common. Anytime you write data past the end of an array, you basically open yourself up to security problems. So Java has a mechanism to catch this. When you guys get to C and C++, it won't. It'll let you fuck shit up good. There's an expression. We like to say that C++ is like a sawed-off shotgun. You can do a lot of damage with it, and you can also blow your own foot off. That's pretty accurate. So you guys are going to get to blow your feet off next semester when you get into programming too. But Java has mechanisms to protect you from that. But do be aware that the bounds of an array are important. It's important to keep track of them, to know where they are, and to not go past them. Okay, so if we look at the way that an array is structured in memory, an array is a reference type. Do you guys remember when we talked about reference types, when we talked about strings? Yeah, exactly. I'm going to repeat what you said, but you're correct. A reference type points, it has basically a pointer. It has a memory address that tells us where our data is. It does not actually store the value itself. So every array, every single one of them, is a reference type. It is, strictly speaking, an object in Java, which means that arrays do have functions and methods and stuff like that, and we're going to eventually take a look at some of those as well. But if we look at the way that it's stored in memory, we have potato, right? Potato is the name of our array, and it points to the memory address where our information is stored. Now, it happens that string is also a reference type. So we have a pointer to a list of pointers. That's basically what we have. We have an arrow that points to a bunch of arrows. So when we go to potato, it goes to this block of memory. And when we go to potato 0, that's what gets us to this value E, and so on and so forth. So this is a subtle but important point, so if you have questions, I would encourage you to ask them. Yes?
Since an array is like a reference type as well, is it also immutable, or is it...
Oh, that's a good question. The question was, since an array is a reference type, is it also immutable? And the answer is, for arrays, no. So strings are immutable, which means you can't actually change them. Every time you do a manipulation, it creates a new string. Arrays are not like that. When you change an array, you actually end up changing the memory itself of the existing array. And this is an important distinction because if you have two things pointing at the same array and you change them from one side, what happens? If you look at it from the other side, you're going to see the change, right? Because you only have one thing that you're actually looking at. You're just looking at it from two different angles. So it's really important to remember that most objects, and for arrays this is true as well, most objects are not immutable. They can be changed. They are mutable or mutatable. We can change them. So does that answer your question? And then somebody else, yes?
I'm not, okay, so when you declare an integer, why isn't that referencing something?
Oh, that's a good question. The question was, when you create an integer, why isn't that a reference? So basic, like fundamental data types, comparatively speaking, they're very small. So rather than storing an address where the data is, they just store the data itself.
They're storing the name and the value there?
Right, so they're just storing the data straight up. Whereas a reference type is storing a memory address rather than the data itself. It's saying the data is over here at this memory address. Does that make sense?
So where is it storing?
So basically, let's see here. So we have this, if you have an integer, if I have an integer tomato, right? Then inside of tomato, it wouldn't have like, this is an arrow, that just means a memory address, it's a pointer, right? But if you have an integer, it doesn't actually store an arrow. It actually just holds the number itself, because the number is small, right? The number is only like 4 bytes. But if you have a complex data type, like a string, some strings are like hundreds of bytes long, right? So instead of storing the actual object in that variable, it stores a memory address. That way, it's easy to get to it and change it, and it also allows you to use the same memory for multiple purposes. Does that make sense? Anyone else? Yes.
So, an array is an object, but an object's not always an array?
Right, so the question was, an array is an object, but an object is not always an array, and that is correct. So anything that is a reference type in Java is an object. Array is one type of object. Does that make sense? Anyone else? Okay. What do we got? We got 15 minutes. So, that... Oh, yes, go ahead.
Why didn't you specify how many values are in that?
Oh, that's a really good question. The question was, how come I didn't tell it how many values are in the array? And the answer is, in this case, I'm declaring an array literal. When I declare an array literal, I don't have to tell it how big it is. Does that answer your question? Speaking of telling it how long it is, let's take a look at another example. Don't set me off. So in this example, we're going to use a slightly different syntax. Let's say that I want to create an array, but I don't know what I'm going to put in the array yet. Then I can create a new object using the new syntax in Java. So this is something new. This is something we haven't seen yet. When we use the keyword new in Java, it means we are generating a new object. Usually a new object that we want to point to. So in this case, I'm saying I have a string array reference potato, and I'm going to create a new array object, and I want it to have 2 values in it. That's what this syntax means. So this means create a new string a new string array with 2 references in it, with 2 different objects I can access. So we're going to end up using this new keyword a lot moving forward, because this is how we create objects when we don't have one yet. There are 2 ways we can create a new object. We can call a method that creates the object, or we can use the new keyword. Those are the 2 ways we're going to end up doing this. So once I've done that, I can directly store stuff in that array with the same syntax. We can treat an array entry as the same way that we treat any other variable. When we access it from an index and we set a value, it's just like setting any other variable. So in this case, we set potato 0 to ini, and that's going to store ini in our potato array. When we set potato 1 to meanie, that's going to store meanie in our potato array.
Since you define it as like a new string of an array of 2 numbers, is that going to count as just 2 individual values, or is it still counting as 0?
Oh, that's a good question. So the question was, well, when I say 2 here, is that counting from 0? This is the actual number of objects. So, if you put 0 in here, you would create an array of length 0, which would have no objects. So this is actually the length of it. So if you create an array of length 2, then it has the indices 0 and 1. But it does not have an index 2. Does that answer your question? Okay. And this is true for most of the C family of languages. Java is not unique in this way. C, C++, the vast majority of languages, actually the vast majority of languages, period, use the same or very similar syntax. So you'll see this a lot in practically any language you use. Anyone else? It's also used in non-C family languages like Python uses the same type of syntax. Okay, so then if we print out potato 0, it's going to show us ini. If we print out potato 1, it's going to show us meanie. Okay. So, one thing we often want to do with arrays is we want to go through the whole array and go to each element in that array one at a time. That's what we call iterating through a list, or iterating through a data structure. So let's say that we had this array, and we want to go through it. What we're going to need is we're going to need some kind of value that keeps track of where we are in the array so far, and that's going to be our counter variable. So I just created an integer that's a counter here, and I started it at 0. So I start counter at the value 0. Then I'm going to have a while loop that will help me go through that array. In this case, I know the array length is 4, so I'm going to say while the value is less than 4, I'm going to continue to loop over and over and over again. So the first thing I'm going to do is I'm going to increment the counter. I'm going to make the value of counter go up by 1. So that'll change the 0 to a 1. And then I'll print out potato number, the counter, and then the value. So that'll print potato number 1, Amy. I know these examples are ridiculous, and I hope that's okay with you. So when I go to the next loop, right? When I finish that, it's going to go to the top of the loop. Counter is 1, so it's still less than 4, so we're going to execute the loop. The first step is we're going to raise the counter, and then we're going to print the next value, number 2, which is me. And we're going to loop again. So we go back up to the top, and 2 is less than 4, so we're going to increment the counter, and it'll go up to 3, and then we'll print out potato number 3. Yes?
Would you want to print out potato of counter minus 1?
It's a good question. Wouldn't I want to print out a potato of counter? You're absolutely right. I have a bug in my code. I have a buffer overflow. So, yeah, okay, I'm going to fix that right now. Yeah, you caught me. Good job. I always appreciate being showed that I've done something stupid. So thank you. Okay, here, I think I fixed. Oh, no, I had it backwards. Okay, let's try this again. There we go. Okay, so, yeah, so I should be going to counter minus 1 because when it's 1, I want to go to 0. When it's 2, I want to go to 1. And when it's 3, I want to go to entry 2, which is going to be miney, right? I'll print that. And then I increment it to 4, and it'll print the last one. Now, when I go back up to the top, and I say counter is less than 4, well, 4 is not less than 4. It's greater than, or it's the same as 4, so at that point the loop will stop and terminate. Yes, go ahead.
Instead of doing that, could you just make counter increase before or after you print out the line?
Yes, the question was, couldn't I make counter increase after I printed the line? And I could, and then I would have, if I didn't change this line, I would have potato 0, 1, 2, 3, which I could also do, if I wanted to. In this case, I incremented the counter so that it would print in like English and not computer counting style. Does that answer your question? But yes, I could have done that. Yes, go ahead.
Just to fix that problem here, can you just use the advanced loop?
Oh, the question was, couldn't I just use a for loop? And yes, you could, and we're going to get to that soon. So yes, if you already know what a for loop is, yes, you could just use a for loop for the same thing. This is the kind of the setup to get to the for loop. So, okay, anybody else? Yes, go ahead.
Can you do an array of integers and characters and everything else?
Yeah, the question was, can I do an array of other stuff like integers and characters and floating points? And the answer is yes. You can do an array of any data type. Any and all data types can be made into arrays. Yes, go ahead. Oh, that's a very good question. The question was, do the data types have to stay constant? Do they have to be the same data type across the array? And the answer is, in Java, yes, they do. In most C family languages, they do. Strictly speaking, in some languages, you don't have to do that. Like Python, you can mix types, but also Python types are not actually technically a contiguous memory array. They're actually a list behind the scenes, like a linked list, which we'll get to later. But yeah. So basically, not in Java. That's the short answer. Does that answer your question? Anyone else? All right. I'm going to wrap up a little early today because I'm sure you're tired of listening to me talk. Have a good weekend. If you have questions, let me know. See you next week.